Hello viewers, we'll look at the properties of real numbers. So what are the properties of real numbers? These include closure, commutativity, associativity, distributive, or you can say distributive law, identity, and inverse properties. So let's begin with the first property. So for closure property, what this means is that if you have two real numbers, let's say you have A and B to be real numbers, so it means they are coming from the set of real numbers, so which could be rational, it could be irrational, it could be even numbers, it could be odd numbers, it could be natural numbers. So what it's saying under addition is saying if you have A plus B is also a real number. So this means that what? The real number, we can say it's closed under addition. Because for example, if you take A to be 2 and you take B to be 3, A plus B is going to be 2 plus 3, which is 5. And you see that 5 is still a real number. We can even take A to be, let's say, pi, and we can take B to be 1. You see, A is a real number because A is irrational. So every irrational is still a real number. And you can see that B is a rational number. But if you add A plus B, what do we get? We get pi plus 1. Yes, pi plus 1 is still irrational, but it's still a real number. So this is saying if you take any two real number, if you add it, the result is still a real number. So we say that the real number is closed under addition. And same applies under multiplication as well. So let's still maintain here A to be 2. So what this property is saying is that if you have A, if you multiply A and B, the result will still be in R. So for example, here we still make A is equals to 2, B is equals to 3. If you multiply A times B, this is just 2 times 3, which will give us 6, and we agree that 6 is still a real number. So maintaining the same A here to be pi and B to be 1, you see that A times B is going to be what? Pi times 1, which is still pi, and we know that this is still a real number. So what we're saying is that what? The real number is closed under addition, meaning this, and it is closed under what? Multiplication. So if you take two real number, you add, you still get a real number. If you multiply, you still get a real number. So for commutativity, we're still using AB. You take AB to be an element of the set of real numbers. So under addition, it's saying that if you have A plus B, this is still B plus A. They are equal. And this is true if you take A to be, let's say 1.2, which is a real number, and let's take B to be, says 0.2. What is A plus B? A plus B is going to be 1.2 plus what? 0.2. And this will be, so A plus B is just going to be 1.4. And if you do it the other way, say B plus A is going to be 0.2 plus 1.2, which is still 1.4. So in general, this is just a particular one. In general, we're saying that what? AB is equals to what? B plus A. So the order does not matter, right? Now for multiplication, is it commutative under multiplication? Is the real number? It means if you have two real numbers, A and B, can we say that AB is the same thing as BA? Does the order matters? Which one comes first? Not really. So if you have, let's take good numbers, For example, take 3. These are just particular numbers. You realize that if you have AB, it's just going to be 3 times 4, which is going to be 12. BA is going to be 4 times 3, which is going to be 12 as well. So we have commutativity when we are dealing with real numbers. So real numbers is commutative under addition, is also commutative under multiplication. So just a question to think about. Do we think that the real numbers is commutative under subtraction? Now, if you take two real numbers, let's say A and B, can we say that A minus B is the same thing as, can we say that A minus B is always the same thing as B minus A? I don't think this cannot be true. So what it's simply saying is that the real numbers is not commutative under what? Subtraction. But for multiplication and addition, yes, it is commutative. Okay, so let's move to the next property, which is associativity. So for associativity, we will need about 3 numbers, A, B, C. Let's say it comes from R. So what this is saying is that if you have A plus B plus C under addition, it's still the same thing as what? A plus what? B plus what? Plus C. While for multiplication, it's saying that AB, you multiply AB first, then you multiply by C. This will be the same if you multiply BC before you multiply by A. Is that okay? So let's take particular numbers. Let's take A to be, let's say 2, B to be 3, and let's say C to be, let's take a negative number. So this means that what? You first of all finish this one. So if you have A plus B first plus C, what does that mean? It means you finish with A with what is inside the parenthesis, right? So you have 2 plus 3, then plus C, which is now minus 1. And the order of operations, we have to finish this. This is 5. It's going to be plus minus 1. So this will be 4, right? And now it means that A plus B plus C is equals to 4. All right, so let's see this one. This one is A plus what? B plus C, which simply means that we go with A first, which is 2, plus B, which is 3, then plus minus 1. And this is going to be 2 plus, this is 3 minus 1, this is going to be 2, and this is going to be 4. So A plus B plus C. Now these are just particular examples, but this is always true for any real numbers you take. So the same, let's apply the same here. We will see that let's just maintain the same A. This is 2 times 3, then you multiply by minus 1. And here, what does it mean? Here says that A first, so this is 2. Then you have to finish what is inside the parenthesis is 3 and times minus 1, right? So if you finish what is here, you will have 6 times minus 1, which is just going to be minus 6. Here as well, okay, let me just go one more step. This is 6 times minus 1. And here is going to be 2 times what? Minus 3. We will all have minus 6 is equals to minus 6. So this is associativity property of real number. So it means the order is not really important. So A, B, you can decide to start with any of the two, either this or this first. Also here, you can decide to multiply the first two before you multiply with the third number, or you multiply with the last two before you multiply with the first one. So this is associative property of real numbers. But this is with respect to addition and multiplication only. Now distributive just involves 2. So I think in this case we can actually combine we can combine both operations. So what it says is that if you have, let's say, a, b, c to be real numbers, so we will have a into b plus c, it's equals to what? AB, so it's going to be a times b plus what? A times c. So this, you can see two operations are already involved. This is multiplication here, and this is addition here. So there is no we don't need to separate it. So this, it means you distribute this a over the multiplication so that we have this. So for example, if you have, let's say, that is why we have, if you have, let's say 2 into let's even say 3x plus what? Plus 4. What does this? This, you take this 2 in, you distribute, so this becomes what? 6x. Oh, let me just go one. This becomes 2 times 3x plus, then you have 2 times 4, and this is simply what? 6x plus what? Plus 8, and this becomes the final answer. Okay. So distributive law involves both multiplication and addition. Now let's talk about identity. So a real number has an identity, but now it now depends on if you are talking about the identity, the additive identity or the multiplicative identity. So what an identity means, for example, if you take any a in R, right? If you take a in R, under addition, the identity, it's simply what? Minus a. So no, minus a, no, the identity is, sorry, it's 0. Why is it 0? Because if we take this a in R and you add what? 0, it's not going to change the identity. It's not going to change the number. So that is why we call it identity, because you're adding it and it doesn't change your number. So we call it identity. Now take, for example, every real number you think of, it has an identity, and that identity is 0. For example, if we take a to be, let's say, root 2 is a real number, right? What is the identity? Is still 0, because if I take this, my root 2, and add this 0 here, this 0, we're still going to get what? Root 2. So it doesn't change our real number. So 0 is the identity. But when we're talking about multiplication, the identity is what? Is 1. And why is it 1? It is 1 because we have that what? If you take any a, if you multiply that a with 1, we are still going to get what? We're still going to get a. So you can see that still the identity does not change. All right. So then the next one is, the next property is inverse, right? So with inverse also, we have, just take any a in R. If you take any a in R, what do we mean by additive inverse? Here we have two things we call additive inverse. The additive inverse is simply minus what? A. Because if you take a, the real number you have, you add your minus a, which is the additive inverse, this is going to give us 0, which is, remember, the identity, right? It's going to give us 0. So what do we do here? For example, you take a to be, let's take a to be minus 2. If you take a to be minus 2 and you're asked to find the additive inverse, the additive inverse is just take the negative of minus 2, which is going to be 2. Because if you look at what is our a now, our a is minus 2. If we add 2 to it, it's going to be what? 0. So this 2 is our what? Additive inverse. So it is the additive inverse of what? Of -2. Right. Then for multiplication, we have what we call the multiplicative inverse. And another one is, we can call it reciprocal. So it's just what? 1 over what? Over a. And it must satisfy this property that if you take the original a that you are given and you multiply it by that 1 over a, which is the reciprocal, or then this has to give you what? 1, which, remember, 1 is also the identity under multiplication. But here we have to be careful that it's not all real numbers that have multiplicative identity. Because, for example, if you take 0, if a is 0, 1 over 0 is not defined. So a 0 does not have a multiplicative identity. So take note, not all real numbers have multiplicative identity. But if you take a real number, for example, let's say we take let's say 1 over 3. If your a is 1 over 3, then the inverse is just going to be reciprocal of this, which is equals to 3. Why? Because if you do 3 times 3, 1 over 3 times 3 is going to give us what? It's going to give us 1. Just a quick example, you can take maybe 2 over 5, right? So what will be the reciprocal, or the inverse? It's just going to be what? 5 over 2. All right. So now let's see some examples. Here we have some few questions. So which one of the following statement is true? Which one of the following statement is true? Here it's saying that every rational number has a multiplicative inverse. Is this true? Now, this is not true. This is false. Because remember, I just explained that what? Remember 0. 0 is rational, right? But 0 does not have a multiplicative inverse. So this is false. And the reason is that 0 does not have, not just that, 0 is what? Is rational. But no inverse. Yes, multiplicative inverse. Does not have a multiplicative inverse. Not have a multiplicative inverse. Okay. Now, B is what? Every irrational number. Every irrational number is not a real number. Is this statement true? Every irrational number is not. This is also false, because we know that every irrational number is a real number, right? So this is also false. Then C, every even integer has a what? Additive inverse. Remember, we talk about additive inverse. Additive inverse means you just take the what? The negative of that number. So take any even integer you like. What are even integers? When we say even integers, you know, starting from where? We can start 0. 0 is an integer, it is even, right? You can start plus minus 2 is also it's also even, it's an integer. All of them, they have additive inverse. So this is going to be what? This is going to be true. Yes. Now, and pi is 22 over 7. So this one we know this is not true, because pi is what? Is is an irrational number, 3.145 continuously. It has a non-repeating and non-terminating decimal, right? So E, the sum of two rational, is always what? Irrational. The sum of two rational is always irrational. This is also false. Also false, because for example, if you take A to be 2 and B to be 1, yes, both of them are what? Both of them are rational. The sum A plus B is still going to be rational, which is 3, right? So the sum of two rational number is always what? Irrational. So this is not, this is false. Okay, so let's move to the last question. Which of the following is also true? So here we are looking for true statement. It says the sum of two irrational number is always irrational. Now this is false, and I'll tell you the reason why is that, for example, take A to be what? Let's take A to be let's say root of 5, and take B to be just the negative minus root of 5. These are what? Both of them are irrational number. But what is the sum? A plus B is going to be root 5 plus minus what? Root of 5. And this is going to be 0. But look at this. 0 is what? It's not irrational, right? But 0 is what? It's rational. So it means that this statement is false. Now, what about this one? The sum of two prime number is always a prime number. The sum of two prime number is always a prime number. Now, this one is what? If you look here, you will see that this is also false. Why is it false? For example, if you take A to be what? 3 and take B to be 5. Both of them are what? They are prime numbers. But what is the sum? A plus B is going to be 8, right? But is 8 a prime number? No. 8 is what? It's not a prime number because it has more than 2 factors, right? It can be divided by 4. Remember, prime numbers can only be divided by itself and 1. Okay, so this one, number C, it says if x is an integer and y is what? Irrational, then x over y is always irrational. Now, think about this a bit. X is an integer, any integer, and y is what? Irrational. Does it mean that x over y will always be irrational? Now, this is also false because let's assume you take x to be what? 0. And you take y to be root of 2, right? So x is what? 0. 0 is an integer, yes or no? Y is what? Root 2. So what is x over y? X over y is going to be 0 over what? Root of 2. 0 over root of 2 is going to be 0, right? But 0 is what? The output 0 is not irrational. It is rational. Do you get it? So you see that this is, so it means that this statement is what? Is false as well. This is also false. Why? Because we have a counterexample here. You take x to be 0, y to be root 2. The quotient, the ratio is 0, which is not irrational. Now, D, every real number has a multiplicative inverse. Now, this is also false. We said it already. False, because A is equals to 0 does not have, right? A multiplicative inverse. Okay? Then, what else? Finally, the product of two odd number is always odd. Yes, this is always true. If you have two odd numbers and you multiply them, what you are going to get is still an odd number. All right, so this has a formal proof, but we'll go into that. Just think of any two. If you have a counter example, then just put it in the comment section. But I think the product of two odd number is always an odd number. All right, so now in this video we've just discussed the properties of of real numbers. But now when you want to talk of the property, you have to be very careful. You need to mention you need to mention your set, you need to mention the operation, either you are dealing with addition or multiplication, and also you need to mention the property itself. So for example, we can say that the real number, when we say the real number, it means we have mentioned the set is closed. It means we have mentioned the property, that is closure. Under addition, we have mentioned the operation. So three things are very important. You mention the set, you mention the property, and you also mention let me just put it here. You mention you need to mention the set, you need to mention the property, and also you need to mention the operation. Okay, so the set, for example, it could be real number, the property could be closure, and here the operation could be addition. Now why this is important is that we see that now what does this mean? Let's go back here. You can see that. Let's rephrase this statement here, the B here. Look at B. We said the sum of prime numbers is always prime, and we say it's false, right? It means that if you add two prime number, you don't necessarily get a prime number. So what does this mean? This simply means that the set of prime numbers does not have the closure property. In other words, it is not closed under which operation? Sum, under addition. So it is not closed under, so you can see that the prime number is not closed under addition, right? But the real number itself is closed under addition. So that is why it's good you mention the set as well. All right, thank you for watching. If you have any question, just feel free to put it in the comment section.